Hello and welcome to today's Independent Travel Podcast with me, SimonCalder. It's Tuesday the 18th of June and I am glad to be in the company of a man who I've actually written quite a lot about his work because he is Professor Paul Williams. He's Professor of Atmospheric Science in the Department of Meteorology at Reading University. But more to the point, he is Professor Turbulence. Hello, Paul.
Hello, Simon. I've been admiring you from afar from as long as I can remember. So it's a great pleasure to meet you finally today after all of these years of following you online.
Well, how very kind. So we're 4 weeks since Singapore Airlines Flight 321 from London Heathrow to Singapore unfortunately hit very severe turbulence. I followed your work and it appears that actually it could well be that climate change is an element in that.
Yes, I've been studying turbulence and specifically the kind of turbulence that affects aircraft for the past 10 years or longer. And the basic question is, what's climate change doing to this turbulence? And the evidence now has built up. We have a catalogue of evidence, including satellite observations, computer models, basic physical theory about how turbulence is generated, and they're all telling a consistent story, which is that indeed there's more turbulence because of climate change. 55% more severe clear air turbulence, that's the invisible kind, over the North Atlantic today compared to 40 years ago, and a projection in a worst case scenario over a doubling or even a trebling of the amount of severe turbulence in the atmosphere in the next few decades.
That sounds extremely dangerous, extremely worrying.
Potentially, but here's the slightly better news. I'm not saying that 55% more flights are encountering turbulence today than 40 years ago. I'm saying there's 55% more turbulence in the atmosphere. That doesn't necessarily mean more flights are encountering turbulence because lots of things are changing. Today we have better turbulence forecasts, which means pilots are better able to plot smoother flight routes and avoid the turbulence. And even the aircraft designs themselves, a modern aircraft has a much better response to turbulence. It moves up and down much less than one of the previous generation. So lots of things are changing. Yes, the atmosphere is getting more turbulence in it, but that doesn't necessarily mean more turbulence on flights if we take some of these mitigating actions, these countermeasures to make things better.
Well, talking of countermeasures, I understand that you believe that quite a lot of climate change is actually, unfortunately, already baked in, but there are technologies being developed which could see us flying in a way that burns less carbon. Are there any that you're particularly optimistic about?
Yes, I think there is some low-hanging fruit. I think flight routes, for example, across the North Atlantic, very busy part of airspace, and for decades really there has been a set of tracks published daily across the Atlantic which all aircraft have to fly on, whether you're going from Heathrow to JFK in New York or from Barcelona to Chicago or any airport pair. You're forced along these routes which are not very fuel efficient. They're not the shortest distance, they're not the shortest time. Fortunately, today those tracks have been partly abolished, at least up to a certain flight level, and so now aircraft, because of better situational awareness from improved satellites, we've been able to relax these rules, the air traffic controllers at NATS, and now aircraft flying from Europe to North America can choose, if they want to, the most fuel efficient route finally, and I think we'll see not massive fuel savings, but something around the 1-3% level, and it's better than nothing, so I think we'll take it.
And finally, you have also commented on some of the extraordinary high-speed transatlantic crossings. And I dare say some listeners may remember you because you've been quoted when lots of sub-6-hour transatlantic flights have come in. Are those becoming more frequent?
Possibly, yes. And certainly in the future, we expect, according to the state-of-the-art projections, that this jet stream, this current of air that gives us the tailwinds on the eastbound flights is going to speed up and perhaps already has started to speed up. And what that means is that, yes, we'll see, well, unfortunately on a westbound flight, that means stronger headwinds and a longer journey time, so perhaps a delayed arrival into North America. But happily, on the eastbound flights, shorter journeys. And is it a coincidence or not that the subsonic eastbound transatlantic flight time crossing record has been broken 3 times in the past decade. It was 5 hours and 16 minutes, then it was 5 hours and 13. Now it's actually under 5 hours. It's 4 hours and 57 minutes. Is it just a coincidence? It's too early to say, but I certainly think that in future we can expect that record to be broken increasingly frequently as the jet stream speeds up, as we expect it to.
And just finally on that record, that's going from New York to London?
That's the standard reference point for a transatlantic flight. I think it was from JFK to either Heathrow or Gatwick, and you've reached the limits of my memories on that particular record.
Well, we're very grateful for your wisdom on this subject. Professor Paul Williams from the University of Reading, thank you very much indeed.
It's been a pleasure. Thank you, Simon.